There are these creatures that came from off-world. These are untouchables. NASA, renowned for its critical disclosures, has really uncovered that this new planet isn't simply hypnotizing considering the way that of its size and district. Yet in addition, since it shows lights that have every one of the stores of being phony, are we essentially uncovering insider real factors that could change our impression of the universe? Could this divulgence sooner or later mean there is life on various planets? Accompany us as we look at NASA's enchanting disclosures and uncover reality with regards to these astounding lights. In 2007, NASA transported off the Sunrise space apparatus with a mission to investigate the most spellbinding articles in our close-by planetary gathering. Daybreak was uncommonly furnished with 3 particle motors, permitting it to embrace an excellent excursion. Daybreak's excursion started with a 14-month examination of Vesta, the second biggest space rock in the belt. During this time, Daybreak sent back definite pictures and information uncovering Vesta's baffling surface and different land narratives in the wake of finishing its essential goal at Vesta. First light separate out on the second, and maybe most beguiling piece of its undertaking, a nearby assessment of the Bantam planet. Ceres, due to its particle motors, first light had the option to leave Vesta's circle and embarked on a mission to arrive at Ceres, an accomplishment that conventional compound impetus would have found. Testing these motors given a determined delicate push empowered first light to travel tremendous distances proficiently and enter a steady circle around Ceres. Previously found in 1801 by Italian cosmologist J.P.I. Pi, Ceres is the biggest item in the space rock belt among Mars and Jupiter. For quite a while it was viewed as the littlest Bantam planet in our nearby planet group until its renaming in 2006 with a breadth of around 950 kilometers. Ceres is the biggest and most huge body in the space rock belt and one of the most enters because of its special qualities as sunrise high level toward Ceres. Researchers enthusiastically expected the primary nitty-gritty photos of this unusual world. They saw splendid spots dispersed across its surface, most strikingly in an enormous cavity currently known as a crater pit. These splendid spots ignited prompt revenue and theories among standard researchers. Before Sunrise's central goal, the best picture we had of Ceres was a foggy low-goal photo taken by the Hubble Space Telescope. Specialists had hardly any insight into this Bantam planet, and the chance of at last getting a nearby view was elating. What insider facts would Ceres uncover? What new revelations anticipated the mission? Sunrise vowed to improve how we might interpret the close-by planetary gatherings. Improvement and the job of water in molding planetary bodies. The brilliant spots on Ceres were not normal for anything seen on different space rocks. They appear to be made of profoundly intelligent material, conceivably salts abandoned by sublimated water. This prompted the chance of cryovolcanism on Ceres, a cycle where volcanoes eject with water or briny fluids rather than liquid stone. Yet what precisely are these puzzling lights, and what do they uncover about Ceres? Could they be proof of progressing geographical movement or something considerably more unprecedented? Ceres remains from other divine bodies in the space rock belt because of its size, mass, extraordinary synthesis and potential for water and ice. Dissimilar to most rough space rock, Ceres has a structure more likened to a comet. Proposing it holds a greater number of privileged insights about the early nearby planet group than we at any point envisioned. Following 2 years on its excursion, the Daybreak shuttle at long last started its way to deal with Ceres in mid-2015. This second denoted a significant accomplishment in the mission, as Sunrise had the option to convey human ties first. Close-up perspectives on the biggest article in the space rock belt. As Sunrise moved nearer, the photos of Ceres developed progressively itemized, offering looks at a world recently covered in secret. The principal pictures uncovered a surface specked with cavities, normal for a long history of effects. Anyway, it wasn't the pits that grabbed the eye of researchers and space devotees. The same among these elements were bizarre, brilliant spots that unmistakably appeared differently in relation to the hazier, unpleasant scene. As the photos kept on further developing in gold standard, researchers hummed with speculation about the idea of these splendid spots. Were they ice patches reflecting daylight, or might they at some point be something substantially more vivid? Hypotheses went from mineral stores to potential indications of cryovolcanic action. Unquestionably, nearer examination uncovered that the most splendid spot was not a particular substance, but instead an assortment of a few unmistakable spots. This disclosure just extended the secret. The theory that these were stores of salts abandoned by sublimating water get momentum. This would recommend that Ceres had or still has some type of land action fit for shipping water or briny fluids to the surface, where they quickly vanish, abandoning splendid intelligent stores. These disclosures tested existing thoughts regarding Ceres, demonstrating it to be a more mind-boggling and dynamic world than recently suspected. The presence of such Highlights raise the chance of subsurface water or briny pockets, which could have critical ramifications for how we might interpret the potential for life in our nearby planet group. Yet, what makes Ceres exceptional contrasted with different planet series is a charming world frequently depicted as a cool planet with a harsh yet porous surface dissimilar to most space rocks in the belt, which are made chiefly out of rock and metal. Ceres stands apart because of its eminent structure. Its surface is a combination of water, ice, and hydrated minerals, including dirts and carbonates, which give it a fundamentally less thick design contrasted with its neighbors. This organization recommends that Ceres has a lot of water. The surface layer is unpleasant, yet porous with ice and different volatiles caught inside. This chilly trademark is more suggestive of a comet than a normal space rock, demonstrating a history that might have involved a blend of rocky and frosty materials. Digging further beneath its surface, Ceres reveals even more fascinating aspects of its structure. The dwarf planet is believed to have a differentiated interior, consisting of a slushy mantle and a core. The mantle is thought to be rich in water ice, making up around half of Ceres' total volume. This mantle, possibly a mix of rock and salty water, surrounds a core that may be composed of denser material, possibly silicates. The presence of such a significant amount of water ice suggests that Ceres may have once held liquid water, particularly if its core was heated by radioactive decay early in its history. This internal structure sets Ceres apart from its asteroid neighbors and raises intriguing questions about its potential for geological activity and the role of water in its evolution. But that's not all. The discovery of ammonia clays on Ceres suggests that the dwarf planet may have formed in a colder region of the solar system before migrating inward. The presence of ammonia lowers the freezing point of water, supporting the possibility of subsurface brines. These insights into Ceres' structure and history not only enhance our understanding of this captivating dwarf planet, but also provide valuable clues about the processes that govern the formation and evolution of icy bodies throughout the solar system. Cryovolcanism is a fascinating and relatively rare geological process, especially when compared to the more familiar volcanic activity on Earth. Unlike traditional volcanoes that erupt molten rock, cryovolcanoes, also known as ice volcanoes, erupt volatiles such as water, ammonia, or methane. These substances can exist as liquids or gases in the extremely cold environments where cryovolcanoes are found. On Ceres, cryovolcanoes function by allowing water mixed with dissolved salts to reach the surface. When this briny water interacts with the vacuum of space, it rapidly sublimates, changing directly from a solid or liquid state to gas, leaving behind bright, reflective salt deposits. These salt deposits form the mysterious bright spots seen on Ceres' surface. The most famous of these bright spots is located in a crater named Achater, specifically in a region known as Spot 5. This area has attracted significant attention due to its high reflectivity and intermittent hazes observed by the Dawn spacecraft. These hazes are believed to be caused by the sublimation of water, suggesting that cryovolcanic activity may still be ongoing or may have occurred relatively recently. Additionally, Ceres has several other bright spots, each with its own unique characteristics. These spots are not confined to one region but are scattered across the dwarf planet's surface, indicating that cryovolcanism may be a widespread phenomenon on Ceres. The presence of these bright spots highlights the remarkable nature of Ceres and raises important questions about the potential for life in our solar system. The dynamic and evolving nature of Ceres challenges previous assumptions that it was a geologically dead world. As the Dawn spacecraft provided more detailed images of Ceres, an abundance of surface features began to emerge. The surface of Ceres is dotted with various craters, each telling a story of the dwarf planet's history. Some craters are relatively shallow and eroded, indicating an ancient surface that has been subjected to numerous impacts over billions of years. Others are better preserved, with sharp edges and deep basins, suggesting more recent impacts. Interestingly, the number of craters on Ceres is lower than initially expected. This discrepancy points to geological processes that may be resurfacing the planet and erasing evidence of older impacts. One hypothesis is that Ceres' icy crust allows for a form of cryovolcanic resurfacing, where subsurface materials periodically rise and cover older features. This ongoing geological activity suggests that Ceres is not a static world but one that has been, and may still be actively evolving. Additional evidence of surface deformation on Ceres comes from the observation of fractures, grooves, and ridges on its surface. These features indicate that Ceres' crust has experienced significant stress and stretching. Some of the fractures appear relatively young, possibly only a few 100 million years old, suggesting that the crust is still somewhat active. The ridges and depressions on Ceres likely formed as the crust was stretched and pulled apart, while lines of mountains and compressional ridges indicate areas where the surface was pushed together. These contrasting features provide insight into the complex processes that have shaped Ceres over time. The presence of a large dome-shaped mountain in one of the craters suggests the possibility of internal pressure or upwelling of materials, possibly linked to cryovolcanism. This feature, along with the extensive network of fractures and ridges, points to a dynamic and evolving surface. Dawn's mission has also revealed intriguing surface compositions beyond the bright spots and reflective salts. NASA's data has uncovered a range of surface materials that are crucial for understanding Ceres' geological history. For example, specific areas on Ceres exhibit a dark, fine-grained material that contrasts sharply with the brighter salt deposits. This darker material is believed to be a type of carbon-rich substance, possibly organic, adding another layer of complexity to Ceres' composition and suggesting a potential for prebiotic chemistry. The interaction between these materials and the icy surface could play a role in the chemical processes occurring on Ceres. Furthermore, the discovery of organic compounds on Ceres has sparked significant interest in astrobiology. Organic molecules, which are the building blocks of life as we know it, have been found in carbon-rich deposits. These findings are particularly exciting as they suggest that Ceres may have conditions suitable for the development of more complex organic molecules. The presence of these compounds opens up possibilities for life, or at least the building blocks for life existing on this dwarf planet. Another remarkable feature is the large number of mysterious dome-shaped structures on Ceres. Some of these domes reach heights of up to 6 kilometers and are believed to be the result of subsurface processes pushing material through the crust. Their shapes and sizes suggest that they may have formed from cryovolcanic activity or internal pressure forcing materials upward. Understanding these formations is essential for unraveling Ceres' geological history and internal structure. Moreover, the gravity data collected by Dawn has provided insights into the internal density distribution of Ceres. Variations in gravity reveal the presence of different layers within the dwarf planet, suggesting that Ceres' interior may have complex structures, including a possible subsurface ocean or briny pockets. These discoveries are crucial for understanding Ceres' thermal history and its potential to support conditions favorable for life. Overall, the Dawn mission has not only expanded our knowledge of Ceres but has also transformed our understanding of small celestial bodies in the solar system. As more data is analyzed, scientists hope to unravel the mysteries of this fascinating world and its potential to provide insights into the broader processes that govern planetary evolution and development. The future of Ceres exploration. With the remarkable discoveries made by NASA's Dawn mission, scientists are eager to further explore Ceres and its potential for geological activity, water reservoirs, and even the conditions necessary for life. While Dawn provided a wealth of data, many questions remain unanswered, and future missions could provide deeper insights into this mysterious dwarf planet. One of the most intriguing possibilities is the presence of a subsurface ocean or briny pockets of liquid water beneath Ceres' icy crust. If liquid water still exists, it could significantly increase the chances that Ceres hosts prebiotic chemistry or even microbial life. The existence of water-rich environments in the solar system has long been a key focus for astrobiologists, as liquid water is essential for life as we know it. Future missions to Ceres could involve a lander or rover to directly sample the bright salt deposits, which might contain frozen remnants of past cryovolcanic activity. A subsurface probe or ice-penetrating radar to investigate the depth and structure of Ceres' possible underground water reservoirs. A sample return mission to analyze organic compounds and other surface materials with high-precision instruments on Earth. An orbiter with improved sensors to study Ceres' gravity, composition, and surface changes over time, which could indicate ongoing geological processes. Ceres' role in the bigger picture. Studying Ceres isn't just about understanding one dwarf planet. It helps scientists piece together the broader puzzle of solar system evolution. Ceres' unique mix of rock, ice, and organic material makes it an essential case study for understanding the formation of icy bodies, the potential for habitability beyond Earth, and even the origins of water in our solar system. Furthermore, Ceres' relatively accessible location in the asteroid belt makes it an ideal candidate for future exploration, possibly even as a staging ground for deeper space missions. If Ceres contains usable water, it could serve as a valuable resource for future human missions exploring deeper into the solar system. What's next? While no upcoming missions to Ceres are officially planned, scientists continue to analyze Dawn's data, refining models of its internal structure, surface composition, and possible geological activity. As technology advances, the possibility of sending new robotic explorers to Ceres becomes increasingly feasible. With its cryovolcanoes, mysterious bright spots, and potential underground water, Ceres remains one of the most enigmatic and exciting worlds in our solar system. Whether it holds the key to understanding early planetary formation, the presence of water in space, or even hints of life, Ceres is far from finished revealing its secrets.